Okay, so here's where we left off last time. We created some, we read our data in from using pandas from our Excel spreadsheet, and we sort of we created little sub data frames from that data by using the iloc function with a set of row and column coordinates. Okay, so let me show you how to plot that data. So let's go down to step 2. I'm just going to get rid of this row a second. There you go. Right, step 2, plotting. So a bit of blurb here. If you do need to know, so I'm going to use matplotlib to make all of my plots for this video series. There are loads of other libraries that allow you to make really nice visualizations. If you like, go and explore those. We've created some HiPy resources for those, and you can check out the links here. For any documentation, and I do encourage you to read the documentation surrounding any library or function to do with matplotlib by going to matplotlib.org. There are thousands and thousands of examples which are pre-prepared. I always like to find the one I need and sort of cut and paste the code and format it how I like. So what we're going to do here is we're going to take those data sets that we've just created, and we are going to plot those. Right. So we're going to plot those two on the same graph. So the first thing to do is, at the moment, all that data exists in 2 data frames. Okay, copper_1 and copper_2. Now that's not terribly useful for me at the moment. I really want to reduce those data frames into, for each of them, 2 lists. One of X data and one of Y data. Okay, so to do that from a data frame, let's just get the X data from our copper_1 data set. So this is going to be a list. Call that variable there, and I'm going to use an NP array. Okay, so I'm calling NumPy, and I'm telling it to generate. So I'm telling it whatever's coming next is going to be an array or a list of data. Open brackets. I'm going to call my pandas data frame, copper_1. I'm going to specify the first column in that data frame, which is column 0. So all the X data, and I'm going to use the .toList function. ToList, and then it's open bracket, close bracket. And then to complete, I'm going to close that last bracket there. And watch that done. If I just run this line, oops, and I type x1 here and output that, you can see it's got an array from 0 up until 4000, which is the which is actually the X values in that data frame. For the Y, I do exactly the same, copper_1, but I'm going to specify the first column rather than the ZDoth column. Okay, and again, ToList. Okay, and if I output the Y, you see, I've got and the 3 dots here means that there's lots of data in here. Now, the reason why these are all 0 is because at the very ends of my spectra, I'm getting 0 counts. But somewhere in between, I'm going to get those peaks. So we'll worry about that in a second. Let's plot it. Let's get the data for the copper2, which is my gain 4. So I'm going to do, let's call it x2 equals np.array copper_2 this time. Again, ToList, and y2 equals np.array copper_2 .toList, bump bump. And now let me just run that to make sure it's fine. Oh, I've got an error. Let's have a look. Key error. That's because I've used the wrong one. So I'm still using it's maintained the column names from the original data frame. So it's 3 and 4. There you go. Looks good. Right, so I've got my data ready. I now need to plot it. Now, there's 100 ways you can do this, but I like to create an actual figure, which I'm then going to add, a figure object, I should say, which I'm then going to add an axis to. So I'm going to use this line. Now this is a pretty standard matplotlib line. Figure comma axis, or ax, equals plt. So I'm calling the matplotlib library, which I've imported above. And then I'm going to use the function subplots. Okay, now don't worry about too much about that line right now. I'm going to leave it as it is. now I'm going to plot my data on an axis. So I created two variables there. I created a figure object and then an axis, which actually sits on that figure object. Okay. So to make my plot, I use ax.plot, and I'm going to do the x and the y lists there, x1, y1, and I could just leave it at that and it would plot, right? But I also want to make sure I specify a label for what each of those are. So I'm going to use a string that's going to be called gain equals 2. So I'm basically telling whoever sees this graph that the data here is for copper and for a gain of 2. Ax.plot. I'm now going to plot the x2 data, and that's for a gain of 4. Right. Okay. Now to quickly see what that's going to look like, I need to. So I can run this now and nothing will happen. Okay. It's just going to spit this out. It's telling me it's created an object, but to get that to work, I'm going to you have to use plot plt.show. Okay. If I do that, you can see I've got the data. Now for some reason it always does it twice, so I'm just going to run that cell again. There you go. So I've got my copper, my gain equals 2 and my gain equals 1, and I've got 2 peaks in each of these spectra, and one of those is the K alpha and one is the K beta line for my X-ray fluorescence spectra. Okay, a few things you should always do, and if you don't, I'm going to hunt you down, is you need to set labels for your axis. That's really, really important. So I'm going to do, actually the first thing I'm going to do is I'm just going to readjust my axis so the data looks a bit more presentable. So I can rescale my x-axis by using ax.set xlim, and I'm going to go from channel 500 to 2500. Okay. There you go, and that'll just rescale that data. Looks a bit better, doesn't it? Okay, let's set these axis labels and titles then. So that's really easy. Ax.set x label, and that is going to be channel. And ax.set y label, I'm calling it intensity, which is sort of for this RB units, right? Okay, and I'm going to set a title which is a bit more descriptive. Let's call it XRF scans for copper. Right. The one thing I haven't done as well is put a legend on here, so that's really easy with, as long as I set the labels when I've played these plots here, if I do ax.legend, that'll just put those into a nice box in whichever column that matplotlib, but whichever corner of my plot that matplotlib feels is best. Let's just do that. There you go, plot done. So now there's a couple of ways to get this out. If you wanted to use it in a figure, you can do a right click and a save image as, but that's only going to save it as with a resolution that's as high as it is here. If you want something which is sort of a high resolution, I definitely recommend using this line here, which takes your figure and saves it as an EPS file, an encapsulated PostScript, and that essentially vectorizes your image, so you can rescale your image for any resolution and it will look good. You're not going to get any sort of blocky pixels or anything like that. Okay, so I'll just run that again. That's it for this video. The next video, I'm actually going to show you how to start fitting these peaks with Gaussians. It's going to heat up a bit. I hope that was useful. I'll see you in the next video.